Around 230,000 years ago, northeast China was transformed by a brief and forgotten breath of warmth. This was marine isotope stage 7E, a temperate interlude during the glacial rhythms of the Pleistocene. Today, Harbin is known for its icy winters and frozen rivers, but during that ancient warm spell it was something else entirely. A landscape of wide rivers, marshy wetlands, sprawling grasslands, and thick deciduous forests teeming with life. And it was here, in this forgotten Eden, that one of the most mysterious branches of humanity may have flourished, the Denisovans. Long before the icy claws of later glaciations crept back over the region, the Songhua River basin in what is now Heilongjiang province offered something rare, an ecological corridor for early humans to move, settle, and evolve. Massive herds of mammoths, woolly rhinos, and ancient bovines thundered across the plains, and wherever such game existed, archaic humans followed. But for decades, no one had suspected that such a remote and frigid modern location once harboured ancestors of humankind. That changed dramatically with a skull. The fossil now known as the Harbin cranium, or dragon man, surfaced in a way as strange and dramatic as its anatomy. The tale begins not in prehistory but in 1933, at the height of geopolitical chaos. Japanese troops had invaded northeast China, building infrastructure and forcing local workers into service. One such labourer, so the story goes, was involved in the construction of a bridge over the Longjiang, the Dragon River, near Harbin, when he unearthed an enormous human skull, unlike any he had ever seen. Fearful of surrendering it to the Japanese occupiers, and perhaps to hide the fact that he was working with them, the man secreted the fossil away and buried it in an abandoned well. It remained hidden there for over 80 years, surviving war, revolution, and the radical upheaval of Chinese society. The man, consumed by guilt or secrecy, reportedly told no one until his deathbed confession. Or so the story goes. But doubts remain about this story, and some suspect that the fossil was discovered more recently. In 2018, the man's grandson retrieved the skull and handed it over to Chinese paleontologist Ji Qiang in a secret meeting. The man refused to give his name and vanished. But what he left behind would upend decades of scientific assumption. It was the best-preserved archaic human skull ever found in East Asia. The Harbin skull is immense. With a cranial capacity around 1,400 cubic centimeters, rivaling or even exceeding that of modern Homo sapiens, it displays a strange blend of features: thick, prominent brow ridges, a broad and flat face, an enormous nasal aperture suggesting cold adaptation, and unusually large teeth. Yet its overall proportions are remarkably modern. At once archaic and derived, it's a face that bridges epochs, a frozen mosaic of evolution. Though initial radiometric dating of sediments stuck to the nasal cavity placed the fossil at about 146,000 years old to 309,000 years, and many paleoanthropologists suspect it could fall in the middle. Morphologically, it fits closer to 230,000 years ago, in the heart of that interglacial haven when the Harbin region would have been a livable frontier for human migration. This matters enormously because it suggests that archaic humans, likely ancestors of the Denisovans, had already colonized the high latitudes of Northeast Asia by this time, taking advantage of the warm conditions to establish footholds in places previously too cold to inhabit. The Harbin lineage may have arisen in isolation here, shaped by the unique ecological pressures of the region. And what lineage exactly does Dragon Man represent? At first, Ji Qiang and his team proposed a new species, Homo longi, named after the Dragon River. But subsequent genetic and proteomic analysis told a more familiar story. Though DNA was frustratingly absent from the fossil's dense cranial bone, scientists managed to extract mitochondrial DNA and proteins from dental tartar. The results were unmistakable. The Harbin skull belonged to the Denisovans, the elusive sister group to Neanderthals, first identified not by their bones, but by a girl's pinky finger from a cave in Siberia. This changed everything. Prior to Harbin, Denisovans were ghostly figures known only from molecular echoes in Asian genomes and fragmented fossils from caves. The Harbin skull gave them a face, a full cranium to study, compare and classify. It was the first Denisovan skull, and with it came the realization that these people were not obscure fringe dwellers. They were robust, adaptable, and genetically influential across the breadth of Asia. In fact, this fossil may be the strongest argument yet to abandon rigid species classifications in human evolution. Svante Pääbo, Nobel laureate and pioneer of ancient DNA, declared that the concept of species in human evolution is no longer useful. Denisovans interbred with Neanderthals. They interbred with Homo sapiens. Their children were fertile. Their genes live on in modern Melanesians, East Asians, and some indigenous American groups. Morphologically, Dragon Man is closer to us than many fossils once considered transitional species. The idea of Denisovans as a separate species, alien, distant, is no longer tenable. They were human in every meaningful way. But to understand what this means, we must return again to that moment in time, 230,000 years ago. The interglacial warmth didn't just melt ice, it reshaped ecosystems. In East Asia, rivers surged with snowmelt, forests surged northward, and herds migrated into fertile valleys like Songhua. In this temporarily green world, archaic humans could range wider than ever before. They built tools, Acheulean-style bifaces, now with local variations. They likely cooked food, hunted game, used fire deliberately, and may have even practiced early symbolic behavior. The Harbin individual, or his ancestors, were not exceptions. They were part of a regional expansion into new ecological niches, one that mirrored the expansion of Neanderthals into Europe and Homo sapiens into Africa's grasslands. Some have speculated that the Harbin skull could be the missing link between northern Chinese Homo erectus and later Denisovan groups. Others suggest it represents a hybrid, the product of mingling between Denisovans and lingering Homo erectus populations. This would explain its unique blend of archaic and modern traits that echo earlier fossils like the 1 million-year-old Yongxian skull, yet also foreshadow features seen in our own species. The molecular analysis also supports this hybrid theory. DNA extracted from Denisovan bones in Siberia reveals traces of introgression from a mysterious super-archaic ghost population, perhaps late surviving Homo erectus or another branch of early humanity. The Harbin lineage may be that ghost, or at least part of its final chorus. If so, then this skull is more than a face for the Denisovans. It is a monument to a vanished world of hybrid humanity, of populations once distinct and isolated, now lost but not forgotten, living on in the bloodlines of modern people across Asia and Oceania. And yet, how little we truly know. The Harbin skull's true age remains a mystery, its exact provenance a question mark. The man who brought it forward disappeared, possibly fearing legal consequences or public attention. The fossil was nearly lost to history for a second time. Had the well collapsed, or the man stayed silent, we might never have known what Denisovans looked like. Instead, we now have a keystone specimen. With this cranium, researchers can now re-examine other fossils, like the Dali skull, circa 270,000 years old, the 300,000-year-old Hualongdong bones, and the recently studied Denisovan jawbone from Taiwan. Each may now be properly situated within a broader Denisovan mosaic, rather than scattered in isolation. Harbin gives them context. Harbin gives them kin. If anything, the fossil invites us to reconsider the whole framework of human evolution in East Asia. For years, the region was thought to be peripheral, a cul-de-sac of hominin development overshadowed by Africa and Europe. That view no longer holds. Instead, we now see East Asia as a crucible of hybridization, innovation, and deep ancestral lineages. The Denisovans were not a side branch, they were a central player. And during that crucial warm window 230,000 years ago, they likely expanded, thrived, and diversified, possibly becoming the dominant hominin form in the north. So perhaps it is time to discard the name Homo longi. Perhaps it is time to even discard the word Denisovan as a species label and begin to speak of them not as other, but as us, as another form of Homo sapiens, as varied and real as the Neanderthals and the early moderns of Africa. Human evolution was not a tree with neat branches. It was a river system, with channels that braided, separated, and rejoined. The dragon man, entombed in mud for perhaps 2 ice ages, has given us a new course to follow. A skull born in a forgotten warm age has come back to tell us that the past was never simple. It was human, and it was never truly gone. For over 5 decades, the story of human origins has been told as a straight line. According to this prevailing tale, Neanderthals, Denisovans, and other ancient humans were cast as evolutionary dead ends. But a new archaeological discovery from a cave in southwest China has detonated this overly simplistic narrative. The find is so mind-blowing, so paradigm-shifting, that it compels a complete rethinking of where we came from, how we lived, and how many ancient cousins we may still carry within us. In Longtan Cave in Guizhou province, archaeologists have uncovered a set of stone tools that mirror a distinctly Neanderthal technology previously found only in Europe, Kina Musterian. These thick, resharpened scrapers, marked by stepped retouching and expert flake removal, are the hallmark of Neanderthal craftsmanship. Their sudden appearance 10,000 kilometers, more than 6,000 miles, from their European heartland changes everything we thought we knew about the boundaries of Neanderthal movement, culture and influence. The Kina tools unearthed at Longtan are unmistakable. They exhibit steep retouching used to create rugged, durable working edges. These were not casually flaked rocks. They were purpose-built instruments of survival, designed for the scraping of hides, the shaping of wood, and the dismemberment of bone. These tools demonstrate sophistication, standardization, and longevity. What's more, they were repeatedly resharpened, a sign of planning and a deep understanding of resource efficiency. These techniques had been thought to belong solely to Neanderthal populations in Western Europe and the Levant, yet here they are in a Chinese cave made by hands that lived and died 50,000 years ago. Who were these toolmakers? Were they Neanderthals themselves? Were they hybrids? Or were they local populations who had absorbed Neanderthal techniques through contact or cultural diffusion? Complicating the picture even further is another discovery from central China, the Xuchang skulls. These 100,000 to 125,000-year-old fossils from Lingjing in Henan province are an anatomical puzzle. They exhibit a strange combination of traits: low, wide cranial vaults, typical of Eastern archaic humans, alongside distinctly Neanderthal features such as the occipital bun and inner ear structures. These skulls may not be pure Neanderthal, but they are certainly Neanderthal adjacent. The discovery of the Xuchang skulls has provided significant insights into the presence of Neanderthal-like features in East Asia. These findings reveal a complex mosaic of archaic and modern human traits, suggesting intricate patterns of human evolution and migration in the region. The endocranial volume of the Xuchang-1 skull is approximately 1,800 cubic centimeters. This places it at the high end of Neanderthal and early modern human variation. Unearthed at the Lingjing site in Xuchang County, Henan Province, the 2 partial crania, designated Xuchang-1 and Xuchang-2, exhibit a unique combination of features. These include characteristics reminiscent of early Middle Pleistocene Eastern Eurasian humans, as well as traits shared with both archaic and modern late Pleistocene humans elsewhere. Notably, the skulls display a low, sagittally flat, and inferiorly broad neurocranium aligning with Eastern Eurasian ancestry. One of the most striking aspects of the Xuchang crania is the presence of features typically associated with Neanderthals. These include aspects of the occipital bone and inner ear structures, such as the labyrinthine proportions of the temporal bone. Such features are rare among earlier Eastern crania and suggest some level of population interaction across Eurasia during the late Middle and early late Pleistocene. The Xuchang findings challenge the traditional view that Neanderthals were confined to Europe and parts of Western Asia. Instead, they suggest that Neanderthal-like populations, or at least populations with shared ancestry, may have extended their range into East Asia. This supports the idea of a more interconnected, prehistoric world, where gene flow and cultural exchanges occurred over vast distances. Furthermore, the combination of archaic and modern features in the Xuchang skulls aligns with the hypothesis of regional continuity in human evolution. The Shuchang skulls provide compelling evidence of the complex tapestry of human evolution in East Asia. Their unique blend of features underscores the need to reconsider simplistic models of human migration and development. As research continues, these findings will undoubtedly play a crucial role in shaping our understanding of the diverse paths that have led to modern humanity. Together, the Shuchang crania and the Longtan tools create a portrait of Eastern Eurasia as something far more complex. It was a cauldron of diversity where ancient humans experimented, interbred, and exchanged ideas. And yet for decades, this entire region was excluded from the main plot of our evolutionary story. The presence of Neanderthal-like tools and skull features in China demands a serious look at migration routes. There are two main corridors that could explain how these cultural and biological traits moved so far east. The Central Asian steppe route, running from the Caucasus across Kazakhstan into the Altai Mountains, and then dipping into western China, and the Himalayan foothills route, which would trace the southern edge of the Tibetan Plateau from India through Nepal and Myanmar into Yunnan and Guizhou. During warmer interglacial periods, such as marine isotope stage 5, around 125,000 years ago, these routes would have been passable and rich with game. The skulls from Shuchang date precisely to this time, suggesting that some archaic groups had already made the journey long before the 50,000-year-old tools were left in Longtan Cave. The Longtan artifacts may represent a later wave of migration or a long-standing hybrid population maintaining traditions across millennia. Either way, they destroy the idea that Europe was the sole cradle of innovation and that Asia was merely a quiet backdrop. Fossils like the Shuchang skulls and tools like those from Longtan were long considered outliers, anomalies to be explained away. The possibility that Neanderthals had a wider range or that hybrid populations lived deep in Asia was simply too messy for the clean lines of the prevailing theory. As a result, an entire continent's worth of evolutionary history was marginalized. Whole cultures, possibly whole species, were forgotten. It has taken finds like these to shatter the dogma. The human story is a braided stream, populations flowing, merging, splitting, and sometimes rejoining over tens of thousands of years. Asia was not a silent witness. It was a dynamic arena of innovation, interaction, and endurance. We now understand that human evolution did not follow a linear path. The Quina tools in China and the Shuchang crania tell us that complex technological traditions and population mixing were not exceptions, but the norm. Innovations didn't come from one place, they emerged in many. Neanderthals, Denisovans, archaic East Asians, and early modern humans were not separate actors. They were neighbors, competitors, and sometimes partners. The people of Longtan Cave were likely part of that tapestry. Whether they were full Neanderthals, Neanderthal-Denisovan hybrids who had adopted foreign tool-making techniques, they represent a vital chapter in the human saga, a chapter we are only now beginning to read. These fossils were often dismissed as anomalies or transitional. Entire tool cultures, like the ones recently uncovered in Longtan Cave, were overlooked because they did not match expectations. The possibility that Neanderthals might have had lasting legacies outside Europe, cultural, technological, or genetic, was treated as a fringe hypothesis. Even when fossil evidence, such as the Shuchang skulls, or technological parallels like Quina tools, appeared thousands of miles away from their presumed origins, they were often brushed aside as coincidental or contaminated by dating errors. The fossil and archaeological evidence from Eurasia, especially East Asia, has long hinted at a much more complex reality. The Shuchang skulls do not look like modern Homo sapiens. They retain robust archaic features, but also show traits previously thought unique to Neanderthals. These findings should have sparked a revolution in understanding, but instead they were often framed as mysteries rather than what they truly were, challenges to orthodoxy. Similarly, the presence of Quina Mousterian tool types in southwest China should have been front-page news in paleoanthropology. These tools, traditionally associated with Neanderthals in Europe, demonstrate technological convergence or direct migration into regions previously considered outside Neanderthal range. If a Quina-style scraper is found in France and another nearly identical one in Guizhou province, China, That means either the knowledge travelled or the people did. Either scenario destroys the notion of cultural isolation and supports a mosaic, not a monolith. Neanderthals didn't vanish overnight. They left behind tools, bones, behaviours, and possibly even hybrid descendants who carried both their genes and their ideas. The discovery of Kina tools in China and the evidence of Neanderthal-like skulls in Xuchang help untangle that braided stream. They show that Eurasia was a vibrant, active realm where evolution took its own path, parallel, intersecting, and at times indistinguishable from what was happening elsewhere. The revelations from Longtan Cave, Xuchang, and similar sites across China are part of a larger reckoning. And that truth, written in the scars of Kina scrapers, the curves of ancient skulls, and the winding paths through the steppe and forests of Asia, is this: the evolution of our species was never a single spark in one corner of the world. Paleoanthropologists have proposed a new theory. Some human fossils from China may be Denisovan Neanderthal hybrids. We already know that Neanderthals migrated all the way to the Altai Mountains, a mountain range in Central and East Asia where Russia, China, Mongolia and Kazakhstan converge. But just how large was the Neanderthal and Denisovan geographic range, and when did interbreeding occur? While fossils from Europe that date to between 400,000 and 40,000 years ago are classified as Neanderthals, even though they have a high degree of variability, Chinese fossils are not categorized as a single species. This may change with the new discovery of the Denisovans. Based on genetic research, it is understood that the Denisovans diverged from the Neanderthal branch approximately 400,000 years ago. Therefore, it is reasonable to anticipate the presence of certain Neanderthal characteristics in their physical structure, which is further supported by indications of interbreeding with Neanderthals at a later stage. The Marber cranium has been dated to approximately 120,000 to 140,000 years ago. Found in a limestone cave alongside Pleistocene fauna, the fossil consists of a partial skull with a prominent brow ridge, a relatively flat face, and an estimated cranial capacity of 1,300 cubic centimeters. This places it within the lower range of Denisovans and Neanderthals. Marber exhibits several traits that suggest a potential connection to Denisovans. Its prominent brow ridge is one of the most notable features, bearing some resemblance to Denisovan morphology. Its cranial capacity falls within the range of Neanderthals, though on the lower end. Furthermore, its occipital region shows slight bulging, a feature often associated with Neanderthal skulls. However, significant differences complicate the classification as Denisovan or Neanderthal. Marber lacks the pronounced mid-facial prognathism that is a hallmark of Neanderthals. This absence of forward-projecting facial features aligns it more closely with other archaic humans or transitional populations. Moreover, the geographic location of Marber in southern China raises questions about the easternmost extent of Neanderthal migration, and whether its Neanderthal-like traits could be explained by gene flow rather than direct ancestry. While they share some similarities with Neanderthals, such as robust cranial features, their divergence from classic Neanderthal morphology points to the complexity of human evolution in Asia during the Middle Pleistocene. One reason that classification of the skulls has been problematic is that Marber is more gracile than most Neanderthal skulls. An often overlooked but obvious conclusion is the skull are female, hence their more gracile appearance. In fact, the Marber cranium has been compared to the Sacco-Pastori skull from Italy and the Steinheim skull from Germany, both likely early female Neanderthals. Based on the determination that the Sacco-Pastori Neanderthal skull is a female, it is reasonable to infer that the Marber cranium may likewise belong to a female individual. Additional examples of female ancient humans is the Jinushan skull from northeast China, which also compares to the Marber cranium. In any case, the possibility that Marber represents a Denisovan Neanderthal hybrid raises important questions about the geographic range of this species. Neanderthals are traditionally thought to have been confined to Europe, the Levant, and parts of Western Asia. Nonetheless, genetic evidence of Neanderthal admixture in modern Asian populations suggests that Neanderthals may have had a broader range than previously assumed. If MABA represents Neanderthal Denisovan populations, their morphology may reflect adaptations to local environments or interactions with other hominin populations. This possibility aligns with the growing body of evidence that Middle Pleistocene Asia was a dynamic region where gene flow between different hominin groups played a significant role in shaping evolutionary trajectories. The fossils could represent populations that retained Neanderthal traits through gene flow, while also evolving features specific to their environments. This interpretation would support the idea of a complex web of interbreeding and interaction among hominins during this period, contributing to the genetic and morphological diversity observed in modern humans. The classification of MABA as Denisovan has broader implications for understanding human evolution in Asia. If these fossils are confirmed as Denisovans or hybrids, it would expand the known geographic range of this species and provide evidence of their adaptability to diverse climates and conditions. It would also reinforce the idea of extensive interbreeding and gene flow between hominin populations during the Middle Pleistocene, contributing to the genetic legacy of modern humans. On the other hand, if MABA represents independent lineages or hybrid populations, they underscore the complexity of human evolution in Asia and the need for a more nuanced understanding of how regional populations interacted and evolved. Therefore, while they share some traits with Neanderthals, their lack of key defining features and their distinct geographic and environmental contexts suggest they may represent hybrid populations rather than classic Neanderthals. In the past, many experts considered the fossil to be either archaic Homo sapiens or an Asian variant of Homo neanderthalensis. But with the identification of the Denisovans, many now believe it belongs within this group along with several other Chinese specimens, including the Harbin skull, also known as the Dragon Man cranium. Names hold significant importance in the fields of evolutionary biology and anthropology. However, numerous experts do not agree with the notion that the fossil record of China should be interpreted using a Siberian Denisovan perspective. Species names must adhere to specific rules, such as the principle of precedence. When two sets of fossils with distinct designations are proven to be part of the same species, the name assigned to the earlier set should be employed. Therefore, the term Denisovan should not function as a species designation, and researchers instead use the term Dragon Man lineage to refer to these Chinese Denisovan fossils. Nevertheless, there are those who still hold the belief that ancient Chinese skulls provide compelling proof of Neanderthals' presence in East Asia, and some researchers posit that interbreeding between Neanderthals and archaic humans may have occurred. If the skull reconstruction is precise, the MABA skull has a comparable upper facial morphology to Neanderthals, characterized by a large nose and a thick parietal bone. The flat face and thin cranial vault resemble those of modern humans. However, the MABA skull does not possess the distinctive anatomical characteristics of Neanderthals, which complicates its classification. The MABA skull displays features that are not only diagnostic of Homo erectus, archaic Homo sapiens, and Homo neanderthalensis, but also exhibits traits that are representative of both modern humans and Neanderthals. The severely battered archaic skull discovered in MABA also provides one of the earliest documented instances of human aggression, while also indicating that the ancient perpetrators may have displayed a compassionate aspect. This revelation is founded upon the analysis of CT scans conducted on the fossilized remains referred to as MABA woman. The scans detected a cranial fracture resulting from a blunt impact. According to a recent study, it is likely that the victim was struck with a weapon such as a stone, a heavy bone, or a piece of wood. The impact most certainly resulted in hemorrhaging and a concussion, leading to symptoms such as nausea, vomiting, and potentially even cerebral impairment, rendering her vulnerable and incapacitated. However, the scans also indicated that the wound finally underwent healing, and that MABA woman survived for several years following the incident. This suggests that the injured woman was probably provided with care after her injury. The bone exhibited inward depression, exerting pressure on the surrounding soft tissue. Yet she managed to endure for an extended duration, and it was not the direct cause of her eventual demise. The scientists report that despite the possibility of accidental injuries, contemporary forensic technology and other data strongly suggest the involvement of foul play. This injury bears a striking resemblance to the injuries commonly seen today when someone is forcefully struck by a large, blunt item. It could perhaps be the earliest known instance of interpersonal violence and trauma caused by humans that has been recorded. Another potential scenario is that Maba could have encountered an animal. The researchers are uncertain if a deer antler, although of suitable dimensions, would possess sufficient force to fracture her skull. Notwithstanding this setback, the archaeological findings indicate that the Maba woman survived until her 40s, which is considered a relatively advanced age for an ancient human. The researchers asserts that her recuperation corroborates findings from other paleontological investigations, indicating that Neanderthals and other prehistoric humans, despite their frequent displays of aggression, also exhibited a sense of compassion for their ailing and defenseless counterparts. Presumably, she required a period of recuperation and assistance with nourishment and culinary tasks. In a hunting-gathering civilization, she would heavily rely on the assistance of others. Indeed, her rehabilitation would have required a significant amount of time, potentially spanning several days or even weeks. The research team asserts that her recuperation corroborates findings from other paleontological investigations indicating that Neanderthals and other prehistoric humans, despite their frequent displays of aggression, also exhibited a sense of compassion for their ailing and defenseless counterparts. Another potential scenario is that the Maba woman could have encountered a dangerous animal. The researchers are uncertain if a deer antler, although of suitable dimensions, would possess sufficient force to fracture the skull. The cause becomes highly speculative. Did they engage in a dispute with another individual, and did they subsequently wield an object and strike them on the head? Considering the dimensions of the depression and the amount of strength required to produce such an injury, it is also conceivable that it was inflicted using a weapon made by a different species of hominid. Is this evidence of conflict between Neanderthals and Denisovans? We can only speculate. Anthropologists have been astonished to discover a distinctive structure in the inner ear of an ancient Chinese skull, which was previously believed to be exclusive to Neanderthals. This skull, dating back up to 100,000 years, was unearthed at the Shujiayao site in China. This discovery raises doubts about the exclusivity of the layout of the semicircular canals to the Neanderthals. Neanderthals roamed Eurasia for some 400,000 years before disappearing 40,000 years ago, but there is no evidence of their remains east of the Altai Mountains in southern Siberia. It is possible Neanderthals made it as far east as China, or perhaps they encountered other human species in their home territory, an interaction that allowed their stone tool technology to spread eastward. Fossils from Denisova Cave in the Altai Mountains, not far from the Chinese border, show Neanderthals lived there at roughly the same time as their sister species known as the Denisovans, who are thought to have lived throughout Asia. The research also added that skulls found in Xuchang in central China's Henan province also displayed some Neanderthal features, which might indicate that human interactions occurred between the West and the East. Anthropologists would not be surprised if Neanderthals made occasional incursions into Chinese territory. That said, the issue is that we currently lack this technological package in the rest of Asia, leaving us without a clear breadcrumb trail to connect in a hypothetical migration path, the researchers said. An equally plausible explanation is that the hominins who once called China home, perhaps Denisovans or a hybrid species, developed the same style of stone tool as Neanderthals in response to the similarly harsh environment. While we cannot yet confirm the presence of Neanderthals in China, who were responsible for the Middle Paleolithic tools in Europe and Central Asia, we know that their sister species, the Denisovans, were present in the region. It is thus tentatively possible to attribute these innovations and ecological adaptations to them, the researchers said. Starting from a base of knowledge, a technological foundation common to European Neanderthals, local groups might have reinvented this tool-making tradition because it was well suited to their ecological conditions. The only way to prove Neanderthals lived in what's now China is for paleontologists working there to find a Neanderthal fossil in China. While archaeologists and anthropologists long considered Eastern and Southeastern Asia to be cultural backwaters, these discoveries are helping to reverse that narrative and demonstrate that the humans living in these regions were every bit as behaviorally dynamic and complex as humans living elsewhere at the same time.